Okay, so let's talk about the transformations on this one. What are the transformations on this logarithmic function? Down to right 4. All right, so what base log is this? 4. So if I pop to a piece of scrap paper for a second, y equals 4 to the exponent x, what does that table of values look like? -2, -1, 0, 1, 2, 1/16, 1/4. Okay, so we know, sorry, new camera, it's very awkward. It's like, I have to, like, in order, okay, whatevs. So if we're going to do the inverse of that, the original table is going to switch. Right? You guys agree with me? That's the inverse. So that's the logarithmic graph. Right? Everybody good with that? So that's the log graph. And now what are we going to do with that? We're going to apply the transformations to this table here. Not this one. This was the exponential. This is the logarithmic. So we are going to apply the transformations to the second table here. You okay? Oh. I don't really know what's happening, but this is as good as it's going to get. Okay, so what are we doing to the x's if we're going 4 units to the right? What are we going to do to the x's? We're going to add 4. Oh, let's talk about asymptotic behavior. So where did the asymptote happen on your base graph? Where does it happen here? X equals 0, so the y-intercept. So on an exponential graph, the asymptote was affected by the shifts on the y. On logarithm graphs, your asymptote is going to be affected by the shifts on the x. So now where's my new asymptote? X equals 4, but yeah. Well, this one is x equals 0. This one's y equals 0. And so on this one, our asymptote would be at x equals 4 because the whole thing shifts 4 units to the right. So this is going to be 4 1/16. Shall we do all of our x's first? So 4 1/4, 5, 8, and 20. Everybody good with that? And now what's happening with our y's? We're going down by 2, so what's the math associated with that? Subtract 2, so this is going to be at -4, -3, -2, -1, I'm having a hard time counting, and 0. So I don't know if you need the exponential table, but it might be helpful when it's not a base that you're familiar with. Abby, you're changing real estate. I like it. We've made it to May. We decided to change seats. All right, we good to graph? I guess I could have put this all on the notes. Does everybody have those tables copied? Yeah? So I'm good to cover them up. I'll need them in a second. So I think... Do I need to graph it? It'd be nice. Okay, then you can totally, like, you totally can do whatever you like. My y values, they can go up by, my y's are pretty straightforward. So -1, -2, -3, -4, 1, 2, 3, 4. So if you know where your asymptote ended up, let's put that on right now so that we don't get too lost. Now we're just going to plot our points. So at 4 and 1/16, we were at, maybe I do need my table of values. At 4 and 1/16, we are at -4. So really, really, really close to that asymptote, we're at -4. 4 1/4, we're at -3. At 5, so halfway in between, we're at -2. And at 8, we're at -1. And I'm not going to get that 20 on there, just the way it goes, folks, just the way it goes. How do you feel about that? Okay, all right. Don't want to hold you back. So nothing different really there. It's just transformations on a specific type of graph. I got too many pens here. Okay. Now we're going to are you guys good to describe our transformations? Yeah? So right now when we're talking about transformations, it really doesn't matter what the base is. We're just saying what's happening here. So this one, what are we doing? One left. Okay, what about number 2? Always. So this it's not, well, it's kind of a trick question, but you guys have seen it a million times before. And I would expect that you still have that knowledge in your head. You have to do that factoring first, or your shift won't be correct. Your stretch will, but your shift won't be. So this is going to be a horizontal stretch. By a factor of 1/2. And what else is happening? 5 units, right. Ooh, sorry. Okay, is there anything inside the brackets with the X on that next one? No. So there's no horizontal shifts. There's no horizontal stretches. So what's that 3? Vertical shift. And really, you guys know that would look like, I mean, it's nice when the brackets are around it because they're emphasized, but it could be written as this way too. And that's more commonly what you're going to see, and that's going to be the thing that might trip you up. Okay, what about number 4? Okay, let's talk about that negative first. Reflection in the x-axis.
Is it on the exponent?
Nope, it's on the x. Okay, so we have a reflection in the x-axis. We have a vertical stretch. by a factor of 3, because it's vertical. And then we have 2 units down. So stretch indicates multiply, shift indicates an add or subtract. You don't have to write vertical shift down, because by giving me the direction, that tells me that it's vertical. If you want to, just make sure you're using the correct language. Okay, number 5. Right, so I would probably look at this like that first. And then, because there is no bracket pulling that negative out, it is still a coefficient, so it's got to come out. So it's going to be log base 3, -1, x minus 1. Like, your reflection would still be right, but again, that horizontal shift would be wrong. So here we have a reflection in the y-axis, and we have a shift 1 unit to the right. So looking at number 6, it looks almost exactly like number 5. Can you do it in your head without doing the math? Okay, we'll try it. A reflection in the y-axis. We have a shift 4 units right and 1 unit up. And the last one's just a repeat of number 5. Okay. Transformations are super easy, right? Okay, I'm glad I'm here alone today. This is good. Let's graph. Okay, Smarty Pants, you guys are going to do this one on your own. So what would be the first thing we do before we get started? Yeah, I'd switch that around. So ooh. Oh, and I'm not using an erasable pen. Let's try that again. Oh, 2. I was using the base. So you guys have that table. You guys have that table from the very first question that we've done, because we are dealing with base 4. The log base is 4, so we need that original table.
So is it x equals 4y?
Yep. That's the original table. Anything happening to the y's on this table? No. So that's a good question. What do you do first? Do you do your stretch or do you do your shift? Well, there's a reflection. Do you do your reflection and then shift, or do you shift and then reflect? Always reflection because it's multiply, right? Order of operations says we're going to do anything with multiplying first. I think it's hard. Where did our asymptote move to? Move to 2.
The asymptote is 2 or negative 2?
Okay, so where did our asymptote start at? 0. So if we times it by -1, we're still at 0. And then we do our shift to 2. You missed one class, Taylor. One class, and it's all gone. All right, can I show you my graph?
Yeah.
You guys good? No? How about now? So you guys are sitting on your phone texting, and now I have to wait till you're done? You're done everything? Oh, Tanika, I should have never doubted you. Okay, next one. So first thing you gotta do is you gotta look at the base. So your base is base 2. So my original table of x equals 2 to the exponent, that's supposed to be a y. You know what? We didn't talk about domain and range, but that's okay. Did you say who cares? You would never say that. So the transform table Okay, so with the transform table, if we talk about our transformations, we know that we're going 1 unit to the right and we're going 3 up. So we're doing something to both sides now. So where's my asymptote going to be? Should be a positive 1, right? So my asymptote shift to the right 1. So I have to add 1 to everything. I think we found the strategy that doing all of our x's first and then all of our y's is easier for us. And then I'm just adding 3's to my y's. I think you guys are supposed to do this one on your own, but I just took over. First thing I'm going to do is I'm going to put on that asymptote just so I have that nice boundary line so I know I'm not supposed to cross it. Do you guys graph the exact same way every time? Well, like, I always put my asymptote on first. I always do my table of values first. Tirth is shaking his head. He's just whatever strategy at that moment works for you. Whatever comes first. Okay. Let's talk domain and range on that one. I just feel like we haven't talked about it. So we're going to do domain and range just of that logarithm graph. Right. So round bracket around the 1 because we don't want to include it. And we're headed to positive infinity. And my range is going to be negative infinity to positive infinity. Okay, new document camera, not terrible. Yeah. Over and over again? Okay. Which one do you want to eliminate? I'll let you pick one to eliminate. Yep. You want to eliminate the bottom one?
Whoa. I feel like that's the real
True story. But what's different about the first one, the top one? It's got a reflection. That's always fun. And it's got that factoring. So let's do that one together. Because that's got the trick in it. Hey, it's a good time. Okay, what base am I using? Base 3 this time. So a new table again. So x equals 3 to the exponent y. So I find that helpful in the exponential form to do it and write that down first. we're going to have some fractions. Awful. I think I'm going to deal with my y's first. Because really, what am I doing to the y's, mathematically speaking? I'm just multiplying them by, even I can do -2, right? Like just multiplying them by -2. That was good. Okay. So now 1/9 times by 1/3. 1/27th. And I'm going to subtract 1. -26/27. Okay, so now I have 1/3 times by 1/3. 1/9 minus 1. -8/9. 1 times by 1/3 is 1/3. 1/3 minus 1 is going to be -2/3. Oh, thank goodness we're in whole numbers now. 3 times by 1/3. 1. 1 minus 1 is 0. 9 times by 1/3. 3. And 3 minus 1 is 2. Okay, let's talk about where our asymptote is. Where did you go? Which way did you go here? You went left 1. So where's your asymptote? Left. It's going to be at -1, right? So the horizontal shift controls the vertical asymptote. Okay. Let's graph it. So at -26/27, we're really, really close to the asymptote. But which side of the asymptote are we on? We're on the right-hand side of the asymptote. Because we're not to -1 yet. We're just shy of -1. So that's going to be a +4. And again, we're really, really close. We're going to be a +2. -2/3, so just over half. We're going to be at 0. Is that an increasing or decreasing function? It is a decreasing function. Proud of you guys. Word problem. All right. Am I good to flip the page? Are you guys good with that? Okay, perfect. Oh, this is our favorite. Writing an equation to describe the transformations. Again, same strategy you've used on all the ones that we've done. So let's talk about our strategies that we use. So you guys know that this is our original graph, right? Okay. It's labeled, but I'm just going to highlight it. Is there a horizontal shift? How do you know? The asymptote's the exact same. It didn't shift. So we know right away. Let me just write this up here. Y equals A log. Don't know what to call this base. I'll call it K. Oh, you can't see that? Fair. Okay, so what do we know right now? We have no horizontal shifts, so we have no C. And we know that because the asymptote hasn't changed at all. Okay, let's talk about a horizontal shift. No, a vertical shift. We just did that, yeah. A vertical shift. The highlighted one is the parent graph. So we're going to look for a place that the y value on the original graph is 0. And where is that, ladies and gentlemen? It's at 1. So this point right here, because any stretch applied to that, what happens? At 0, this vertical stretch isn't going to matter. So we know at this point, where's that point transformed to? So what do we know D is? So D is a positive 1. So exciting. It does not look like, well, we did our shifts. So let's get our shifts done out of the way. And now let's look at, oh guys, no, that point didn't transfer to there. That's wrong. That's wrong. Exactly. This dot transfers to here. So we don't know where that dot went. Or sorry, we don't know where this point 1, 0 went. It'd be nice if it stayed put. But it did not. Okay, so let's talk about that. What's the height of this graph? We know that this point exists here. What's the height of this graph? Like from this point to that point. You guys with me? 1, right? Where's the x-intercept? Where did it move? Move there. So we know that this graph has a height of 1. Between these 2 points, what's the height? Also 1. So do we have an A value? No. So no A value. Okay, but what do we know if this point translated to that point? So we have no vertical stretch. No vertical stretch. But I was at 4, and now that point translates to 1. So my B value, it was at 4. Sorry. B value was at 4, and it transformed to 1. So what do I have to multiply my 4 by to get it to 1? A quarter. So okay. So I have a horizontal stretch by a factor of a quarter. So I have no C, I have no A, I have no B. Sorry, we have no D. We're looking for the B right now. That's what we're looking for. So what's my B gonna be? 4. So we're gonna have y equals log base 4, because the original graph was base 4. And we're gonna have 4x because of that compression there. That's it. Okay, let's do our next one. Any C value? Any shifts? And I know that because, did my asymptote move? No. I know that there is no D value because what point do they share? They share that x-intercept. Oh, this is nice. Okay, so on the original graph, yeah, the original graph is the top one. So we have point 4 and 1. It transforms to, and this might be helpful to write it out like this, transforms to 4, -3. And what do you notice that there should be as well here? There's a reflection in the x-axis, hopefully, right? This one is above, this one is below, so there should be a reflection. So we anticipate that being, there to be a reflection in the A value. So what do we notice? Did the x's change at all? Nope. So B, there's none. So we're looking for A at this point. So if I was at 1 on the original graph, and I moved to -3, what did I multiply by? -3. Because it's a multiply at this point, because we said we have no shift. Whatever, buddy. Letters are hard. Log, oh, geez Louise. I need an erasable pen. Who left me in charge? Y equals -3 log base 4 x. All right, you guys good with that? Sure. I love it. Okay, here's your welder helmets. Welder helmets. Helmets fitted with a filter shade to protect the eyes from intense light and radiation produced by welding. Filter shade number N is defined by the function given there, where T is the fraction of visible light that can pass through the filter, and shade numbers go from 2 to 14, with a lens shade number 14 allowing the least amount of light to pass through it. So 14 is the darkest. The correct filter shade depends on what type of welding you're doing, and a shade number of 12 is suggested for arc welding. There you go. There's a little tidbit to take away from today's class. What fraction of light passes through the filter to the welder as a percent to the nearest 10,000ths when you're arc welding? Okay, first of all, you're arc welding. What's my shade? What's my number? 12. So we're going to substitute that in. What are we trying to solve for? T, because T is the fraction of visible light. I love that I'm here today by myself. This is awesome. I really need to use an erasable pen. What's the base on the logarithm? What's the base on the logarithm? 10. Extra super special bonus points if you remember what that's called. Logs with base 10. Common logs. Look at you guys. Extra special bonus points. All right. What do we do? Ooh, I missed a +1 there. Thanks. Subtract 1 from both sides. And the 3 is just over the logarithm, so we can go ahead and subtract that 1 because that doesn't have a denominator of 3. So we're going to have 11 equals 7 minus log capital T over 3. Pardon? Yeah, times both sides by 3. Get rid of that 7. Because really what we're trying to do is isolate that log. So 33 over 7 equals negative log T. Any suggestions on this point? take away the negatives, so we have negative 33 over 7 equals log t. Okay, so that was just the algebra that you guys have done a million times before. Now what do we do with this thing? Suggestions? We will need our calculator for sure, but we need to do something prior to that. You're on the right track, but you're not using the right language. We're going to change it to exponential form. Ah. So what's the base on the log? 10. So my base is 10. So is my exponent t, or is it negative 33 over 7? Negative 33 over 7. And that equals my argument of t. Now we're going to need our handy-dandy calculators, but this is just exponents. Okay, but it doesn't want that. It wants it as a percent. Times it by 100 to get to the percent. That's not a lot of light. Oh, it wants it to the 10,000ths. So what place value is that? To the 9. So 0.0019%. Oh, very rare do we round to the 10,000th place. Okay, that's all. That's it. Easy peasy. Okay, I hear no one screaming.